Synthetic HVAC filter media. It's lower. Everything about it is lower. So the specific attributes of synthetic HVAC filter media are lower cost, lower initial statics, lower square feet of media within the filters, lower real-world particulate efficiencies, and all of that ends up with a lower dust holding capacity. So the big driver on synthetic medias and why they became so popular and why we still have them around today is they are lower cost. They're significantly less for us to manufacture, which allows us to make a little bit more money on this type of filter and offer it at a lower price to end users. When we look at kind of just generic pricing for a MERV 14 synthetic 4-inch mini pleat, it's only $35. Compared to its fine fiber counterpart, comes in about $20 higher, right around $55. When we go to kind of the upper end, the 4V V-bed mini pleated filters, synthetics again, right around $85 a piece, whereas the fine fibers considerably more, up hovering around the $120 a piece. Well, static pressures. This is kind of another thing that made synthetic medias look like a home run. Made them look really, really good because we had a correlation that is made between the initial static pressure and the energy that the filter is going to use. If we have a lower static pressure, that means it uses less energy to move air through it, which is true, but how quickly does that initial static go up? We'll talk about that in a moment. But initially, when we look at it on a piece of paper, a 4-inch mini pleat synthetic MERV 14 is going to have an initial static about 4.5 tenths, compared to 6 tenths for fine fiber. In the V-bed style, that gap isn't quite as large, as the synthetics are right around 2.5 tenths, and the fine fibers are up around 3 tenths. So again, these lower static pressures, the manufacturers jumped on the chance to make these really, really simple energy calculators. But there was two main assumptions that were wrong with these energy calculators. One is they assumed a linear dust loading curve, and that just doesn't happen. Dust loading curves tend to be exponential. They'll stay low and low and low and low, and then they'll kind of hit a point of loading where the pressure drop goes up rather quickly. Each filter and each MERV would need a different calculation if we were really going to do an energy calculator correctly and accurately to what is going to be realized in the real world. The other wrong assumption that's made with these oftentimes is that the synthetics are going to last just as long as their fine fiber counterparts, meaning that rate of increase in pressure drop is going to be the same between a synthetic and a fine fiber media. And again, in situ testing has proven ever since these have been out that doesn't happen either. Synthetics load much faster than fine fiber filters. They just get their air cut off much faster because of how the dust holds in the media, a lot due to the fact that synthetic medias will have a lower dust holding capacity, and that dust holding capacity is all determined on how quickly the filter reaches final static pressure. So again, kind of looking at the square footage of media in a filter, when we look at a synthetic 4-inch mini pleat, we have about 3 pleats per inch. So for a 24-24 filter, you wind up with about 49 square feet of media. The fine fibers, however, we can actually put up to 5 inches or 5 pleats per inch, giving us 110 square feet of media. The V-bed filters in a 4V V-bed pack, made a little bit differently than the 4-inch mini pleat pack. We have 6 pleats per inch for a synthetic media, given, again, in the industry average about 135 square feet of media for a 24-24. The fine fibers, again, we've got 9 pleats per inch. We get up near 200, and some manufacturers right at or a little over 200 square feet of media in their fine fiber 4V V-beds. Considerably more media. Hold considerably more dust before reaching that final pressure. And really an air filter comes down to efficiency. I mean, the reason we would even purchase a high efficiency filter is because we're thinking it's going to take more stuff out of the air, and we would purchase a filter, or from a manufacturing side, we would want to supply a filter high efficiency, representing that this is better because it's going to take more stuff out of the air. Right on page 3 of ASHRAE's 52.2 standard 2012 revision, they couldn't start any worse for synthetic medias than this, but they say right on page 3, synthetic filters may demonstrate high efficiency when clean and drop in efficiency during their actual use cycle. It goes on to say the initial conditioning step of the dust loading procedure described in the standard, also known as Appendix J, may affect the efficiency of the filter, but not as much as would be observed in actual service. Therefore, the minimum efficiency observed during the testing may be higher than that actually achieved during actual use. So again, I can't say it any more plainly. There's enough impartial testing out there that ASHRAE felt compelled enough to put this right on page 3 of the 52.2 standard. Looking at the medias up close, we get a better feeling of why that static pressure is lower and why that real-world efficiency is different. On the left, you've got the fine fiber media. Each strand of media averages about 500 nanometers in diameter, whereas the fine fibers, much larger, coarser fibers, are about 4,000 nanometers in diameter. Quite a bit more. You can also see all the open space in the synthetic medias. That's why the initial statics are lower. But again, not only is the square footage of media lower, the actual amount of media within itself is lower. Those coarse fibers, there's just not as much fibers there. The fibers often rely on a static charge to pull dust particles, especially the small dust particles, to the fibers. And once the fibers become loaded, now they're insulated, and that charge doesn't reach out and grab those small particles like it once did. Fine fibers rely solely on the media itself to strain those small particles out of the air. Once that charge is gone on these synthetic medias, the old rumor is that, well, the longer a filter's in service, the more dust it gets on it, the more efficient it is. Well, that's not the case in high-efficiency filters because the size of the particles that we're taking out of the air are so small that they simply cannot add up to a large enough mass to aid in the straining effect of the filters, especially when the gaps between the fibers are as large as they are in modern synthetic medias. So kind of tying all of these points together winds up in a lower dust holding capacity. Lower dust holding capacity means shorter life, and you reach final static, you have higher static pressures sooner. So any initial energy savings is quickly used up and gone away once the filters begin to load. And when we compare synthetic variants of wet laid fine fiber medias, which would be predominantly your mini plates, and as we saw earlier, it's just a significantly lower amount of media per square foot, limits the dust holding capacity. You just don't have as much there to catch dust. When we look at synthetic variants of air-laid fine fiber filters, the square foot per filter of media is going to be about the same. However, the fine fiber filters, like the rigid deep pleateds and bag filters, have a very highly lofted media, and this loft adds depth to the filter media, which will give you a very, very high amount of depth loading in the filter. Save a lot of places and a lot of strands of media for the filter to catch, and then allow air around those particles and around those other fibers. So you have very, very high dust holding capacities compared to the square footage of media. We just can't get that lofting currently out of the coarse synthetic fibers. So again, that will limit its dust holding capacity. So at the end of the day, really all you're getting with synthetic medias is something that's cheaper when you first purchase it. But the long-term impacts of it are pretty horrible when you're not getting a filter that stays at the efficiency that you're purchasing it for, and you need to wind up replacing them more often than you would a fine fiber media. The initial difference in cost is far outweighed.